Hi everyone, let's talk about significant figures, which is a skill that is important for all chemistry students. To understand significant figures, we'll look at two things. The first is how to read measurements, and the second is determining the number of significant figures in a measurement. We'll start by making sure we know how to measure something with the right level of precision. When you read measurements, always make sure you estimate one place value past the smallest increment. Let's take this ruler and measure this golden strip of paper. The smallest increment on the ruler is centimeters. Now, I'm not going to record this measurement as 2 centimeters or 3 centimeters because that's not precise enough. I can see that the paper's length is somewhere between 2 and 3. I'll estimate one more decimal place, so 2.8 is the correct way to record this measurement. 2.7 is also okay. What you want is that one extra decimal place. However, don't have too many decimal places. It would be wrong to report this as 2.754 because our eyes can't read things that precisely, so too many decimal places is unrealistic. Let's look at this other ruler. Its smallest increment is 0.1 centimeters, so it is more precise than that other ruler. This time, I would not record this length as 2.7 or 2.8 because the smaller increments let me see that the length is between 2.7 and 2.8. The correct way to record this is to estimate one more decimal place. I can record this as 2.75 or 2.76. There will be cases where your measurement falls directly on the tick mark, but the rule doesn't change. You still want to record one decimal place past the smallest increment. In this example, don't record this as 2 centimeters. Record this as 2.0 centimeters to show that this is exactly 2 centimeters, not 1.9 and not 2.1. If you're measuring liquids, the concept is the same. Let's look at this graduated cylinder with water in it. Remember to read the bottom of the meniscus. This measurement is not 5 milliliters, and it's not 4.5 milliliters. Remember to estimate one more decimal place past the smallest increment, so this can be 4.54 or 4.55 milliliters. Also, don't go too far and say something like 4.543 milliliters. The bottom of the meniscus here is directly on the tick mark. Don't report this as 4.5 milliliters. Add a 0, so 4.50 milliliters. Pay attention to the 0. It's important and it has meaning. It tells us that this is exactly 4.5 milliliters, not about 4.5 milliliters. Digits that are important like this are called significant figures. The purpose of significant figures is to show the precision of scientific data. In the next section, let's look at numbers that are given to us, and we'll determine how many significant figures they have. First of all, any digit that is not 0 is significant. In this number, all the digits are not 0, so they are all significant. This number has 4 significant figures. Next, sandwiched zeros are significant. In 1.023, 0 is sandwiched between non-zero digits, so the 0 is significant. This number also has 4 significant figures. Trailing zeros are significant only when there is a decimal involved. Why is that? Before I explain, remember that significant figures come from the measurements that you read. Let's look at this 20. What kind of measurement will give you this number? If you have a ruler and its smallest increment is 100 centimeters and you have a strip of paper like this, you would estimate that the paper is 20 centimeters. This doesn't mean exactly 20 centimeters. It's just about 20 centimeters. Only the 2 is significant because that's the value you estimated in your measurement. Now, what about 20 with a decimal? How would you get this measurement? If you have a ruler where the smallest increment is 10 centimeters, you would record this measurement as 20 with a decimal to show that this is exactly 20 centimeters, not about 20 centimeters. Both the 2 and the 0 come from your measurement, so this is 2 significant figures. The decimal tells us that this measurement is exactly on that mark. If you have 2.0, there's a decimal, so the trailing 0 is significant. 2.0 has 2 significant figures. So which digits are not significant? Leading zeros are never significant. 0.02 only has 1 significant figure, and 0.5080 has 4 significant figures. Finally, if you have scientific notation, the second part with the times 10 to a power is not significant. In this first example, there are 3 significant figures. In the second example, there are 2 significant figures. Hopefully that helps you understand why we use significant figures and how to identify significant versus not significant digits. Thank you, and I'll see you in the next one.